Hi, my name is Jack, and today I'm going to show you how easy it is to make some simple generative NFT art using only Python. Our first step is importing Matplotlib, which is the standard Python library typically used for making graphs and figures. We'll start by initializing a 5x5 inch figure. I want it to be square for the art, and the size of the figure doesn't actually matter, but 5x5 inches will give us a nice view here in the Jupyter notebook. The next step is adding an axis, which in this situation is just the area available to draw on. I'd like to be able to draw on the full figure, so I'm going to set the borders of the axis as 0, 0, 1, and 1, making it fill the entire figure. We're also going to turn the ticks off and set the margins to 0, so that all of our shapes fill the frame entirely. To generate the art, we're going to basically plot a bunch of shapes on our figure here. So it's important to define the x and y limits, so that none of our shapes get plotted too far out of bounds. Now that we've defined our figure, let's try to display it. I'll set the color of the axis to red so that hopefully we can see it here in the Jupyter notebook. It looks like it didn't show up. Maybe I have to try the figure. There we go. So that is our figure. The first thing I'd like to do is be able to change this background color with a function. Down here we're going to create a new function. This function will accept a figure and a color as its arguments, and it will simply change the background color of whatever figure we give it. You can see here I'm setting the arguments as fig and color, and it's just going to be a one-line function that sets the background color of that figure. It may seem a bit tedious to create a whole function for this single line, but I think it'll streamline our code a bit later. Before we get any further, I'd like to test it and make sure it works. So we're going to head back up to the top here, pass it our figure and the color blue, and there we go. We've got a blue figure. Now comes the fun part. We're going to add a few shapes to this figure. And again, we're going to do this by defining a function. We give the function the axis on which we'd like to add the shape, and a color of the shape that we'd like to add. I want all of these shapes to be unique, so I'm going to give it a random width, a random height, and a random location within the figure. We're going to do this by importing the random library. You'll see by calling random.random here, I'm given a value somewhere between 0 and 1, which is what we set our axis limits to earlier. This step is important for making sure that each piece of artwork is unique. Once our rectangle is fully defined, we can add it as a patch to our plot. We're going to do this by defining a variable, rect. We're going to set it equal to the rectangle with a location xy, a width, a height as defined, and the face color is going to be whatever color we're passing to the function. Lastly, we're going to add the patch to our figure with that last line. And these lines of code here are making use of the Matplotlib module called patches. From patches, we need to import that rectangle class that we called in our function below. And we're going to do that just by writing simply from matplotlib.patches import rectangle. Now, the function that we've used below should work. We should be able to generate a rectangle somewhere on our figure at random. We're going to pass this function the ax and the red color, and you'll see we get a randomly sized and located rectangular patch somewhere on our figure each time we run it. Now we're going to do the same thing with circular patch. You see I just imported the circles class from matplotlib.patches at the top, and we're going to create a new function which again takes the ax and color as its arguments, and will simply add a circular patch somewhere on that figure. For a circle, we don't need to define a width and height, we only need to define the location and radius. And here I'm going to divide the radius by 2, just to make sure that the circles aren't too big for our figure. We're going to pass the circle class our location, radius, and face color. And then again, we're going to add that patch to our given figure. If we go up to the top and test it, it should work. Just about the same as the square. Now we'll have a square and a circle somewhere on this figure at random each time we generate it. The last thing I'd like to do is add a line somewhere on our figure. So once again, we're going to create a function down here. For a line, we need to define 4 random points. There needs to be a starting x and y coordinate as well as a finishing x and y coordinate. So I'm going to create 4 variables here, x1, x2, y1, and y2. And then we're simply going to plot a line using x.plot. The line should stretch from x1, y1 through x2, y2. And again, we're going to change the color of that line to whatever color was passed to the function. Lastly, because we want the line to be able to show up nicely on our plot, we're going to give it a certain line weight. And I want that line weight to be pretty heavy, so I'm going to multiply it by 10. So we're going to get a value somewhere between 0 and 10 for the thickness of our line. If we test it at the top, you'll see, it might be hidden there. Yeah, we get a nice line, a nice white line somewhere on our figure each time. At this point, most of the hard work has already been done. We have a few functions which will add randomly sized and positioned shapes to our figure whenever we call them. Now it's just a matter of calling those functions several times and getting some really interesting pieces of art. Because this video is primarily geared towards NFT generation, we're going to make a function called NFT minter. As its first argument, we'll take the number of mints requested, so this is how many pieces of artwork we'd like to generate, and the desired resolution of each image. Now from the Matplotlib library, we're going to pull in a dictionary which contains a list of named colors and their corresponding hex color codes. On the right here are all of the colors that will be available to us in this list, and these will be the colors that you'll find in the artwork. And of course, you're welcome to change this or use whatever other colors you'd like. For now, this is what we're going to use, so I'm going to import it from matplotlib.colors. And we can do a little test run, make sure that the list that we are asking for is actually a list of named colors. And you'll see there we have it, a list of all the colors that we'll be able to use. These are just the names of the colors. What we'll also need to grab is the actual hex color code for each color. And we do that simply by accessing the dictionary entry in the mcolors.css4 colors dictionary. I'm going to rename it here to colors for convenience, and then we can start our for loop. This for loop is going to be what actually generates the figure and adds the artists for each one of our pieces of artwork here. So first we're going to generate a figure using the above code. So now we have a standard figure created. The first thing we're going to do is change the background color of our figure, and we want to change it to a random color, right? Because we want all of these to be different. So I'm going to grab a random sample from the list of color names. We only need the background to be one color, so I'm just going to grab the first entry from the list of randomly sampled colors. Now what that gave us is the name of the background color. So what we need to do in our function here is take the colors dictionary and grab the hex code associated with that color name. Moving on, we're going to start to add the artists to our figure, and I want to include a little bit of functionality here. I don't want each piece of artwork to have the same number of rectangles, circles, or lines. I want that also to be random. And we can do this in just one line. First, we're going to get a random sample from our list of color names, and that sample is going to have anywhere from 1 to 5 named colors in it. And then for each color, we're going to add a randomly located rectangle to our figure. This is done, again, just by calling the function that we defined earlier. We're going to pass it the ax we want to add and the hex code for the color of choice. The procedure is very similar to add circles and lines to our plot. We're actually just going to use the same for loop here, and the only thing we're changing is the name of the function. Now that we've got the artwork added to our figure, all that's left to do is save it as an image. The Matplotlib library has a built-in function called savefig. All that we need to do is pass it the location we'd like to save. I'm going to save these images in a subfolder called media and give them each a unique name using the index from our for loop. We're also going to save each image as a PNG file, and we're going to set the DPI here, which is the resolution, as the number of pixels we want divided by 5, because our figure size was 5 inches. We're also going to set the bbox inches equal to 0, meaning that the plot will have no white space around it. And we're going to close the figure so that it doesn't display after each NFT is saved. And with that, we should be able to generate some images. All we'll need to do is call this function. Let's say we'll generate 10 with 1000 by 1000 pixel dimensions each. And once we run that, we should be able to see the images appear in the left media folder here. Once we run this function, we do get an error, but you'll see we still generated 10 unique images. They've all got different numbers of lines and shapes and colors, and they look pretty good. We can generate as many of these as we want as well. Because of the way we set up our function, it's super easy just to change that value, and now we'll get 100 unique NFTs instead of 10. And that's really all there is to it. We can head back into the Jupyter Notebook now and clean up the code just to make things a little bit easier to read and understand. So I'll get rid of that starting function, keep all of our defined functions and the generator, It'd be nice if this error didn't pop up, so maybe we take out the bbox inches code there. We may not actually need it. We can see if that still works. Maybe give a little test run. And they look good. I don't think there's any white space on the borders, so I think we didn't even need that. And that's all there is to it. I tried to structure the code in a way that it was easy to understand and follow, so there's definitely room for improvement. I'd love to hear any feedback, comments, or suggestions that you have about this project or any future projects you'd like to see. Thanks for watching, and have a great day.